Alright, hello everyone. This is a special video that I'm making because we just came back from Easter and some exams are coming up, as you know, and I thought this would be a useful and hopefully encouraging video for you to have a look at before you start this kind of final sprint. There's a bunch of things I wanted to say and share with you. Some of them are my personal ideas, things that I've come to learn over the time that I was a student and now still as an adult, and others are sort of things that are well known and everybody would agree on. Hopefully they'll all come in handy. Alright, first thing I wanted to talk about was that most of you have exams in the next 4 to 8 weeks, okay? And if you look back, we are now halfway through April. If you look back 8 weeks, even for those that have the exams in 8 weeks, the year 13 people mainly, if you look back 8 weeks, we're talking about, well, mid of April. It goes January, February, March and April, so we're going to middle of March, no, February, middle of February. If you look back to when February was, so like a couple of months after Christmas, you'll realize hopefully that wasn't very long ago. It's gone really quickly, okay? It goes very, very quick. And this is not in order to scare you, in order to tell you that you don't have a lot of time. You do have a lot of time to revise and to prepare and to improve, but the time is going to go quickly. And what I'm trying to say here is that over the next 4 to 8 weeks, you can imagine everything you've learned up until now. So you're reading and you're writing and all the maths, that you've learned with Miss Pinto, with any other teachers you've had, all the the conceptual thinking that you've come up with, all the data and information you've picked up that you know about physics or about any other subject that you're going to do in exams, in all of this, time that you spend learning all of this stuff is about to come into a focus during a period of a few days where you're going to take these things that we call exams, which our culture have designed in order to see whether you've learned enough stuff. And you'll be surprised how much stuff you've learned over the time that you've been in school. And it's now the time to do this, which is to give some direction to everything you've learned and to condense it into a nice amount of understanding and knowledge that you can then put into your exams. This is a very, very short amount of time if you look at it as a sacrifice. If you're going to work your asses off for 4 to 8 weeks, alright, that's not a lot if you consider everything that you've learned and what the meaning of all this whole stuff that's about to happen has. Okay, this is a really important moment as a student, and when you look back, it'll feel much better if you've actually given it a proper go. Okay, that's the first thing I wanted to mention. Now, the second thing. Second thing is networks. Networks is a fancy word that we've come up with to explain when things are connected, not in a linear way where you have one thing here and then below you have another and then below you have another and below you have another, like in a factory, a chain of events, one after the other. Networks are when things don't happen like that. So things are connected in a kind of net. It's called a network because it's got a kind of a mesh like this, where everything is kind of connected to everything else, and both the knowledge that you have in your minds from what you've learned in the past and the way that the neurons inside of your brain are connected, both have a lot of relationship with networks. A lot of tests have been done in the sense that one doesn't learn things like this, one after the other. One learns things by connecting them. If I tell you now, if I show you a very strange piece of furniture that kind of looks like a chair, when you look at it, you will try to understand it by associating it with this previous idea that you had already in your mind that was chair, and you'll understand it in that sense. And if the object is red, you'll also link it to this thing that is red, and if it looks ugly because it reminds you to something, you'll relate it to something that is ugly, and that gives you a particular feeling. And all of those things are happening simultaneously, millions of them in a second, and we don't really appreciate it, but it's amazing what our brains do with our everyday experience. Okay, the learning at school works in a similar way too. When you learn and you study, it's good to be aware that these networks are going on, because then it becomes part of your emphasis, and part of the partly you get respect for your mind, the way it works, which is a good thing to have, and partly you start to pay more attention to the links between different things, right? So if I'm talking about forces in one of the classes, you can be linking this to ideas about motion and ideas about acceleration. You can be aware of the fact that all of that has to do with the mass, and whether if it's got a very big mass, the thing doesn't move so quickly. And you can apply that at home when you're trying to move something. Maybe you can use a lever at a big distance from a point, so you know that at a bigger distance you can exert a larger force because of the moment, or whatever. All of those links that you can do between seemingly different things are really what makes learning interesting and useful. Okay, it becomes interesting and useful, both things at the same time, when we're able to link all of those things together. So the reason why I say this is because I'm very good with revising for exams. Okay, I was never a student that was doing every day a million hours of studying or anything. I was very good in the last couple of months, always, even at university, to squeeze an incredible amount of learning out of what I'd done before in a short amount of time. So I'm going to give you a few tips here, and hopefully motivational sort of ideas that will give you a hand to focus these last few weeks before the exams. The idea of the networks that I was just talking about has to do a lot with something I've already been telling you in the lessons, okay? But I want to take this to the next level, and I'm actually going to start demanding that you do this part number 3, okay? Everything else is kind of advice, but this part number 3, I'm going to start demanding it, which is that when you do the exam papers that we're going to be doing over the next few months, I want you to do this, okay? And this is really important. I've already mentioned it, but I want to start seeing it. If a question, say, well, this is both for year 11, 12, and 13 for all of them, but if a question says something about the motion of a ball rolling around or whatever, and you're given certain variables, right? You can be given the initial velocity of the ball, and you might be given the time that it takes to get from one place to the other, and you might be given the distance. And by giving you those 3 things, you know already that using these clever equations, which are kind of Newton's laws in the form with the displacement, initial velocity, final, and all of that, it's really F is equal to ma disguised as all of that. But when you're given these 3, you should already know that when you're given 3, you can solve for all the others. So if I'm given U, T, and D, I can also solve for V, and I can solve for A, for example. And the question will generally ask you to find, say, V. What I would like you to start doing is to flood the question, which means at least one extra thing, at least to imagine one thing they didn't actually ask you to do in the question, which they could have asked you given the information, the same amount of information, including what you just found out. Find one more thing at least that they could have asked you as an alternative to the question you just did, and answer that also. I'll give you examples and I'll look at how you're doing it, and I'll let you know. But what this means, okay, so that's one thing. And another thing is that try to write down all the equations. Whenever you're doing a question like this, don't just write the equation they're asking you to do and then move on to the next. Write them all. If just at the beginning, at least until they're so solid in your head that you can't even forget them anymore. You write them all down. U squared plus 2as, the average, formula for acceleration is the difference in the velocities divided by the time. I don't know, I'm missing one. V is equal to U plus AT. All of those, average displacement. Okay, write them all down, and then you'll find that by doing that, the stuff will be much better connected in your mind. The network that I was just talking about, every time you think of something, you're reinforcing that connection between the 2 things that you're connecting every single time. And the more, these are like highways in your brain, the more you travel those highways as you're doing revision, then when you're in the exam, all of these highways will light up, and you'll be able to extract any amount of understanding from there that it will really start to surprise you as we get closer to exams and closer and closer. And this process, what it means apart from doing this extra thing, also writing down all the equations about the topic when you get to the question, just around the question, just around it. It means to flood it is to write around it. You know how I'm doing right now here. You write an extra equation here, and then if you think of another one here, oh, 2 pi divided by t or whatever, just flood the question with stuff around it. Apart from doing the question properly, just flood it with all the things that come to your mind that are sparked by that particular question. Okay? That will take you, if you do it properly, a maximum, it won't take you more than this, a maximum of 50% extra time. So say if you're going to do, you say, okay, every day I'm going to do 1 hour revision, or 2 hours of revision of physics, or 1 hour, or whatever you're choosing to do. Instead of taking you 1 hour, you'll do the same, you'll do one paper instead of in 1 hour and a half or in 1 hour, you'll do it in 1.5. Okay, so that will take an extra 30 minutes. But why am I saying that this is the most worthwhile thing to do? Because for that extra 50% of time that you're putting into it, you're extracting between 2 and 3 times the amount of learning for every single paper that you do. So every time that you sit down, even though you're doing 1.5 of the time, you're doing twice the amount of learning, or 3 times, and it will get closer to 3 times as much as we continue, and it starts to get more and more connected. That is the best use of revision that you can do, where when you're sitting down, it's all starting to link up much more, and instead of just sitting down doing a few questions, getting stuck here and there, not writing very much, finding it a little bit easy, and just or finding it very confusing, depends on what level you are, and just to just answer what's in front of you. This is a much more rich way of studying, and it will pay off. Okay, it will pay off for sure. That's like taking the opportunity of one question to squeeze as much learning as you can from that question. I cannot emphasize enough how important it is to have this skill. It will make your revision 20 times more effective. Well, 2 or 3 times more effective. Okay, having said that, hopefully that makes sense. Having said that, there is very quickly I'm going to introduce you to an idea called categories, which is interesting when you're learning, something to watch out for, and which will help you to connect things as you're learning them. When you're learning about concepts and about ideas, especially in physics, you have 2 types of categories which you can divide things in. Really, you have super categories and you have subcategories. Okay, a super category, for example, imagine that I talk to you about acceleration. Okay, and acceleration is the rate of change of velocity with time. And what about current, electric current in a circuit? That's a rate of change of charge passing a point over time. What about velocity? Velocity is the rate of change of distance divided by time. And power is the rate of change of energy with time. Right? It could be work done or whatever. And so on and so forth. So if you look at all of these, even though they're very different quantities, current, power, acceleration, velocity, whatever, they all have in common this super category, which means that it is above it because it englobes category. It's above it because it englobes all of these individual ideas are englobed by this super idea, which is called rates of change. Okay, all of those are rates of change. They're all rates of change in time, how fast something is changing in time. And if you understand that concept, you can already answer all of those questions under that category. So that's called a super category, and there's quite a few that we're going to be identifying over the next few weeks. And why is this helpful? Because the moment you understand something like that, then everything that is subordinate to that idea becomes much easier to remember. Not only to remember, but also to understand and answer questions about. Okay, super categories are super important. No pun intended. The name is there for a reason. Okay, they're very important. Subcategories are slightly different. For example, if I am teaching about Newton's third law of pairs, for example, that is a super category, right? Newton's laws would be even above, but I could look at Newton's third law of forces as a super category. And what would subcategories be? Well, examples of them. Examples of Newton's third law of forces would be examples that clarify that concept. So if I want to understand Newton's third law better, I look at particular examples. So what are examples? So I'm standing on the earth, right? And I'm missing a section of my body there. It doesn't matter. I'm standing on the earth. That's a mini earth. And there's a force acting on my body downwards, which is a gravitational force. What's the Newton corresponding force? Well, it's not the floor pushing on me, it's got to be the same type of force. This is gravitational, so the Newton's third law has to be gravitational. So it's a force acting on the center of the earth upwards towards me. Those two forces are Newton's third pair law. Another one is if I'm pushing with my hand onto the wall, then I'm pushing into the wall like that, and the wall's pushing on me like this. They act on different objects. One of them is acting on the wall, the other one is acting on me. They're exactly equivalent in size, and they are the same type of force. They're both electrostatic repulsions or pushes or contact forces, as we also call them. Here, again, different bodies. One body is the earth, the other body is the human up there. Different bodies, same type of force, both gravitational, both contact, opposite directions, same magnitude. Those are examples of Newton's third laws. You can come up with a third one if you want. By giving yourself examples of a concept like this, you can better understand it. And if you cannot come up with any examples about a particular idea, you come to me and you ask me, or you discuss it. Even better if you discuss it with yourselves, in between yourselves. Okay, so that's the idea of a subcategory in order to help you understand an idea. And this is a super category which helps you to better sort of to group together knowledge that you already have and make it more accessible, less daunting to remember, and all of those things are useful. So I urge you to notice these things as you go along, and perhaps to use them in your revision when you're making any kind of conceptual revision maps or revision cards or anything like that. You can think you can organize them in those two ways. Okay. The next thing that I wanted to talk about was this idea of respecting your time. Okay, and you need to respect your knowing also, the knowing that you have inside. And this, I don't mean anything mystical or strange, it's very straightforward. Respect your time means if I'm gonna sit down for an hour, this is not a sitting down posture. If I'm gonna sit down in a chair and study for an hour next to a table, I'm gonna be doing stuff here. Respect your time means if I'm gonna put 2 hours of study today when I get home, or 3 hours or 4 hours or whatever I'm doing, make them good, make them useful. What I mean by that is don't have music knocking around in the background, don't have your computer on, your phone on your lap answering to questions. Do you know how amazingly powerful your brain is at concentrating on one area? You can if you get into a little bit of a habit, you can study a particular topic and your brain can really sink into it, understand it really well if you give it some good questions and you give it some food for thought, and it goes, and as time goes on it gets deeper and deeper into the questions. So if I want to study this thing here, my brain is like water, it goes into here and it fills this up. It really gives a lot of feedback, and as time goes on it gets deeper and deeper, more and more subtle, and more able to understand it. The memory goes up like crazy when you spend time doing something. The amount of memory and the probability of understanding it gets bigger and bigger. Your minds are amazing things. If you have the phone next to you, you're texting a girlfriend or a boyfriend, or considering whether you're gonna go out or not every 20 minutes, those 2 hours are gonna be a complete and utter waste of time, or at best they're gonna be 10% as useful as you would have. I don't know how that sentence would end in English, but you know what I mean. Okay, make the hours useful. Okay, that means respecting your time. After those hours, then go and do something else, but the time that you're sitting down, really make it useful. And you can do the test yourself. Sit down one day with music and then sit down the same amount of time a different day without music, and test yourself later, see how much you remember. Okay, you can play classical music, soft jazz or whatever in the background, something really soft, but anything with lyrics that you're tapping your feet to and stuff like that, you're just wasting your time. That's what I mean by respecting your time. Okay, it's super important. By knowing, I just mean if you know that you do better with a silent thing, in a silent room, or you do better without your phone, switch it off. Without the internet, switch it off. That's what I mean by your knowing. Really respect it, okay? Because we're talking about a sprint here of a few weeks, and you're gonna have the whole summer. Okay, so don't say, oh, that's just, I don't know, that's just boring, I don't know what if your brain starts going like that, this is boring, I want to make it more fun, you just ignore it. Your brain's going to say stuff like that all the time, just ignore it. If you always listen to what your brain says, you're going to be a slave to it all your life. Okay, you have a chance not to listen to it. If it's saying, hey, let's put some hip-hop on, just say, no, actually that's a bit stupid, let me give it 1 more hour and then I can go off and listen to music, go and play football or whatever. Anyway, hopefully that makes sense. The next part, perseverance. I can bet with you, or with the greatest majority of you, that by the time, as you get closer to exams, say your exams are here and you're here now, as you get closer to exams, you're going to be like this. There's going to be a feeling of doubt, and ups and downs are where you're happy about it, and this is when you're worried, and then you're going to be a bit happier, and then you're worried, and you're going to be happier, and things are not really connecting, and you're a bit confused, and you're not very sure what's going on. At some point, this starts to happen. There starts to be a incredible increase in the amount of understanding, as you get to the exams, and when you get there, and this can happen in a short amount of time. This could be the last 10 days to the exam, it could be the last week, it could be the last 4 days, but suddenly things start to click together. There's like a domino effect where one domino throws the other, and all your little misunderstandings start collapsing, because you start grouping things in what your mind is, and your ability to do things, and you'll be shocked by how much is possible to learn. Obviously requires all of this time first of battling around, but you'll be shocked how much is possible to gain in confidence between the last few sort of the last period leading up to the exams. You'll be shocked how much is possible here. Okay, and not to do this because you feel a bit confused and you're not getting anywhere is not an accurate guide of what's going to happen. This is the guide, okay, the whole story. And if you don't do this because you're afraid this is never going to happen, you're going to miss out. I recommend that you have a go at it, and you really give it your best, because you'll be surprised how much you actually get to understand by the time you get to the exams. Okay, this is a very brief idea that I wanted to talk about, and it's called taking pride. Don't know what that is. Taking pride means when you give something in. So here's a teacher, and he's sitting there doing whatever, standing or whatever, and you come along with your work and you hand him your work. And what I mean by taking pride means to take pride is to feel responsible for the thing you're handing in. Try to hand in something that's worth the teacher spending a lot of time and effort into marking. I spend a really long time looking at stuff and seeing what people understand, what they don't. It's really important to take pride in what you're giving in and say, this is my work, I'm proud of it, it took me time, I might have not done it all, maybe I only did half because I didn't have that much time, but the half I've done is done well. I've researched it, I looked up things I didn't understand, I called my friends to ask them if they could give a hand when they didn't, I sent an email to my teacher to ask them when I couldn't do it. All of those things are what's important, okay? To take pride in your work means that you learn 10 times more while you're doing it, and it gives you a much better sense when you hand it in and when you get your results back. That's an important idea, to take pride in the work that you're given. Okay, we're nearly finished, so sorry about the length of this, but I think they're useful tips. The next thing is the reason why I really like physics, or the reason why I think it's a very important subject and you might get a lot from it, and why it's worth spending time doing it, even if these are the last 2 months of physics you ever do in your life, is because they help you to do this thing called reasoning in a context that's very clean and very pristine, and it's full of ideas that connect with one another, and if you look at them long enough you can really start to see how they feed into each other. And so the art of entertaining ideas, which is something that every human needs to do if they want to be good at anything, is one that involves, here's a person and they go into a new job, or they want to go to Africa and they want to start a new project there and help or whatever. And the art of entertaining ideas means that I'm able to concentrate or to contemplate an idea for a certain amount of time, and the more I look at it, the more I start to understand it. I start to like shine light on this thing, and by the time I'm done with it, this thing is 20 times more well planned and beautiful and likely to be successful than it was before I looked at it. And that capacity to entertain an idea and to really consider all the different possibilities and everything is something you do with science a lot. You also do it with other more arty subjects, but the way that you analyze it and look for little errors and things that could go wrong, and the way that you are able to focus on it analytically and also creatively, and all of that is all really well trained by doing physics and maths, especially with physics, because it has applications to reality and to actually getting things done. Maths is like the language of all of this process, which is also really important, and it also helps you to entertain ideas. Okay, there's many more reasons, but one of them, and the one that I feel more powerfully about at the moment, is that you can spend 3 hours with a cinema director talking about a very small detail of something that he really wants some feedback from, because you're able to think about things more analytically than he can, and you can be a consultant in that sense for a lot of people who haven't developed that sense for looking at something for a while. That's pretty much it. The last thing I wanted to talk about was this. I know that there are many things in life, okay? There's not just school and exams. You guys probably think that teachers only live for these exams in school life, and I can guarantee there's many more things in my life too. I love traveling, I love doing a million things. It is true that there's many things in life, okay? But my argument here is that we're talking, guys, about 4 to 8 weeks of really giving it your best. Okay, during those 4 to 8 weeks you might have a lot of other hobbies and a lot of other things in life that you want to do, but let's be honest, over the next 4 to 8 weeks the most important thing is this thing now. So just really give it a good go, and don't just sit down and do it passively and just say, I'm gonna study for like half an hour, and then after that half an hour I'm gonna go and do something else. Really put some fuel and some fire and some passion into it. You can really do much better than you think right now, by just changing a little bit the attitude. Okay, I'm not talking to everyone here, I'm talking to some of you. All right, so I'd like to end on a light note, which is that you have the whole summer coming up. Okay, it's coming up super quick, and you're gonna have the whole summer to faff. Faff is a word that I love in English, is to just prance around and do whatever you fancy in that moment. Okay, you have the chance to make music in the summer if you want to. You can go dancing if you like to do that. You can go beaching, or just go to the beach. You can read the novels or the stuff that you wanted to read, the comics that you haven't had time to, if you're inclined to read. I recommend it. It's a great thing, makes you an interesting person. You can travel around with your family, with your friends. You can be around with your girlfriend and boyfriends. You can be flirting, you can be doing sports and painting and writing and laughing, and you can be watching movies, series. Basically, you have all the summer to be enjoying yourself, playing and resting. Don't be afraid of really doing your best and seeing what you're capable of, okay? Not trying hard because you're afraid of seeing how much you can actually do if you did is not a good reason not to try hard. Right? Really, I would recommend you try. You'll be much happier in the summer when you're doing all of this amazing stuff, when you know that you've given it your best. Okay? So that's it. Hopefully it helps a little bit, and I'll see you in the lessons in the coming days. I don't know what that is. Take care.